Okay, so from class, you probably remember that theoretical domain are the values that make mathematical sense in the function. And so we have two rules that we cannot violate. We cannot divide by 0, and we cannot take the even root of a negative number. Those are two math rules we cannot violate. So if we look at number 1, we realize that if we were to divide by 0 here, we would have an issue. So 2x minus 5 cannot be equal to 0, because if it is, we're dividing by 0 and breaking one of our big math rules. So when I solve this equation by adding 5 to both sides and dividing by 2, I find that x cannot be 5 halves. If I were to plug 5 halves into this expression, 2x minus 5, I'm going to get 0, which will be bad because I cannot divide by 0. So my domain is all real numbers. X is an element of all real numbers. That's how we write that. Except x cannot equal 5 halves. X can be every other number except 5 halves, because when x is 5 halves, we violate a big math rule. My second equation, we see that if x plus 4 is negative, we're going to end up taking the square root of a negative. So I know that x plus 4 needs to be greater than or equal to 0, right? Because if x plus 4 is less than 0, we're going to have a negative number underneath the radical, and that's not good. So as long as x is a number that's greater than or equal to negative 4, we will be able to not violate the rule of taking the square root of a negative number. So my domain is x values that are greater than or equal to negative 4, which makes sense because if for some reason I evaluated h of negative 6, I would get the square root of negative 6 plus 4, which is the square root of negative 2, which cannot happen. So in order for this function to be valid, x can only be numbers greater than or equal to negative 4. Please pause the video and on a separate sheet of paper, find the theoretical domain of each of the following functions. All right, so we've got everybody's favorite Kim Ye. They got married in Florence, Italy on May of 2014. So for their first wedding anniversary, Kanye wanted to get his wife roses. How nice, Kanye. So the florist is charging $3 to deliver it and $4 per rose. So we have two variables here. We have the cost that Mr. West is going to have to pay, and we have the number of roses he plans to buy. So let's call the cost C and the number of roses R. And so cost depends on how many roses he buys. So the dependent variable is the cost. The independent variable is the number of roses he buys. Cost depends on roses. So if we write a function for this situation, we're going to write it C of R, the dependent as a function of the independent, because the cost depends on the number of roses he buys. So in order to figure out the cost, I first have to start with the delivery fee of $3. And then for each rose he buys, they're charging $4. So to represent that, we write 4R. So 3 plus 4R is the rule that will give us our cost. So the theoretical domain, we ask ourselves, so this is our theoretical domain, we ask ourselves what mathematical rules were being broken in that function. So remember, the function was C of R is equal to 4 plus 3R. Am I dividing by 0 anywhere in that equation? No. Am I taking the square root of a negative anywhere in that equation? No. So my domain is going to be all real numbers. My theoretical domain, what can theoretically go into that equation. My practical domain, on the other hand, can Kanye give Kim a negative rose? No, not really. And can he give her half of a rose? No, he can't. So my practical domain is any number that's greater than 0. Because he's not going to not buy a rose for his anniversary. He knows better than that. And actually, technically, since we're using the variable r as our input, we should really be writing r is an element of all real numbers, and we should be writing r is greater than 0, just so that we're consistent with the variable that we used in our equation. Just a side note, this came up in my period 1 class. We talked about how technically we should be saying that r for our practical domain is a whole number. Just because you can't have a half of a rose. And so we were talking about, is there a symbol like all real numbers for the whole numbers? And the answer is yes. Z bar is the symbol for the integers, but since we're only talking about positive integers, we would write Z bar and then have a positive in its upper corner. This is the symbol for the whole number set. So that's just kind of a for funsy fact. This is something that I would accept on a quiz or a test. Please pause the video and answer these questions.